And let me click that I got it. And now it is going to go live shortly. It takes so long just to get that together. And there we go. All right, so we are prepared now. Here we go. So today's lesson is going to deal with titrations. I've had several requests for that. And one of the things that we did talk about yesterday, hey, Lexi, hey, Sid. One of the things that we discussed was how to do molarity problems in order to even get to this step on titrations. I know a lot of students that oftentimes have trouble in understanding what titration problems mean. So what I'm going to do today is go through this process with you all step by step. And let me also say this, before we even get started, make sure that you guys stay hydrated. A lot of times students are not drinking enough water. Unless you're an athlete, I know there's a lot going on with the basketball. We've been watching these games left and right. All those men and women are staying hydrated. They got to. Otherwise, they're not going to have enough energy to continue in the playoffs. So you want to make sure that you're hydrated. Make sure that you got your notes, okay, notebook paper, or whatever you take your notes in. Make sure you got your pen, okay, or a pencil, okay, that works too. And also your calculator, okay? And lastly, the sense of wanting to learn. I make sure I say those things because a lot of times, you just be grabbing and going and not really being prepared. Stay ready so you ain't got to what? Get ready. Y'all know. So let me go ahead and walk you guys through a couple of these practice problems. And one thing I can tell you is that if you do all the things that I'm going to mention in my videos, you will ace your next test, okay? You will ace your next test. Now, one thing I want to point out is that on all of my videos, and again, you can go get them on YouTube because I am live on YouTube as well. Learn chemistry with Professor TK the Chemist. Learn chemistry with Professor TK the Chemist. If you have friends that need to get help in chemistry, make sure you share this video with them. Okay? Excuse me. Make sure you share this with them. Why? Because that's what friends are for. Sometimes you may come across information that you want to share with other people, and by all means, do that, okay? Sharing is caring, as the Care Bears used to say back in the day. My sister loved Care Bears, and she loved, I think, the little blue one, if I'm not mistaken, the little blue one or the pink one. I don't remember, but I just know she loved the Care Bears back then. And we know their motto is sharing is caring, okay? So when you share what you've picked up, you get it back times 10, times 10. Ain't that right, Bridget? There you go. So what I'm going to do this afternoon is go through these titration problems, and I'm going to show you guys tips and tricks that you can use to help you on your next test or your next homework assignment or your next quiz. Now, one thing I want you guys to also do when you go through this, if this information is resonating with you all, make sure you continue to tap that screen, share this out with other people, and go also follow me on my YouTube channel so that you can go back and look at the replay of these chemistry lessons, okay? So that you can look at the replay of these chemistry lessons. And also, make sure that you guys are doing the problems alongside me if you don't mind, so we can kind of check our answers together. Okay, so let's go ahead and get into our lesson for today. Hey, Shabazz, how you doing? Thank you, Steppa. Hey, thank you, Vanessa. Thank you, Marisol. I appreciate all those follows and shares and likes. I appreciate all of y'all's support. Now, let me go through the problem with you all and show you what you need to do, okay, in order to figure out how this whole process works. First off, in this particular sample problem, it says a 50 milliliter sample of sodium hydroxide solution is titrated with a 1.605 molarity solution of sulfuric acid. The titration requires 24.09 milliliters of the acid solution to reach the equivalence point. What is the molarity of the base solution? Now, do you all know what equivalence point means? Equivalence point, in case you don't know, What does equivalence point mean? And also, I love when y'all respond back, so I don't bite. You know, if y'all respond back, that keeps me going. Okay, that keeps me going. Okay, so equivalence point is often referred to those types of chemicals, the reactions when you have an acid and a base that are actually coming together, okay, at a certain point in time of your reaction, okay? So when you have an equivalence point, all right, that is the point in which you have two solutions that are used in a titration reaction and they are present equivalent, chemically equivalent, okay? So that means your acids and bases are appearing equal in equal amounts at some point of your process. So whenever you guys are doing these in a lab, you have to be patient when it comes to these types of processes. So in this particular reaction here, you also have to know which one of these is an acid and which one of these is a base. This is why chemistry is repetitive. Things come back multiple times throughout your lessons. So in this particular example right here, okay, you know that sodium hydroxide is your base. So let's go ahead and identify what's given in the problem because they want to know what is the molarity of the base solution. They gave you in this problem 24.09 milliliters of the acid. Right here, it tells you 24.09 milliliters of the acid solution. Make sure you convert that milliliters to a liter, okay? And that's what I've done over here, okay? Now, the next part of your problem, they gave you the molarity of the acid right here. That 1.605 molarity solution of a sulfuric acid, they also provided that for you as well, okay? That's also important. Something else that they gave you in the problem, that's why you see that I'm writing that here, okay? There are 5 things you'll need to fill out. The volume of the molarity, okay, the volume of the acid solution, the molarity of the acid solution, then right here, the mole ratio of base to acids in the titration reaction. So what you've got right here, okay, is 2 moles of sodium hydroxide to 1 mole of H2SO4, which is the sulfuric acid. What is required is the molarity of your base solution. They did provide you with the 50 milliliters of the sodium hydroxide. So that's what I put right there, the 50 milliliters. But to convert that to a liter, you just move your decimal back 3 places to the left, or you can divide that by a liter. I mean, by 1,000, whichever is easiest for you. Okay, so Elle, can you write that question on my last video that I posted on TikTok? So anytime you guys have questions aside from what I'm going over, I don't stop my lesson to answer your questions, but I do request that you put that on my last video so that I can go back and do a video specifically for you for that particular question, okay? So there are several people that have requested certain things and I, do the videos accordingly. Yes, no problem, no problem. So for this problem right here, you were given 4 of the 5 things. You were given the volume of the acid, the molarity of the acid, the mole to mole ratio of the base to acid, and the volume of the base. What's required is the molarity of the base. So what you should do in a problem like this, when you got 2 numbers that are together, okay, meaning if I give you the volume of the acid and the molarity of the acid, you can actually go ahead and do the math for that together, okay? So here's what I mean by that. I'm going to show you right here in this step. Okay, so right here, let me zoom out a little so you all can see that. They gave us the volume of sulfuric acid. They also gave us the molarity of that. So when you multiply those two together, you get your moles. So 0.02409 liters of sulfuric acid times the molarity. Notice right here, guys, where the molarity is 1.605. I also made that, I put the unit for that as moles per liter so that you will know to simply take the molarity and then stick in moles per liter as the units here. So you can cross out the units you no longer need. Okay, so I replace the M with moles per liter because that's what molarity units are, moles per liter or the big M. So I cancel out my liters, as you can see. And now in this blue step, notice that I highlighted that in blue, 2 to 1. I use my coefficients to get the mole to mole ratio. So right here in your balanced equation, I've got 2 moles of sodium hydroxide to 1 mole of H2SO4. So that's where this blue step right here comes from. That's why I highlighted it. Again, I'm going to cancel out my moles of H2SO4 because I don't need that anymore. So now what you need to do is multiply 0.02409 times 1.605 times 2, and then divide that by 1. And you're going to end up with 0.0773 moles of sodium hydroxide. You're going to divide that number by the volume of that base, that 0.0500 liters. And that's how you end up with 1.55 molarity. So that is your answer right there. Okay? So again, when it comes to titration problems, you've got to read the problem, yes, but you also need to make sure that if they did not provide you with a balanced equation, you've got to write out the chemical reaction for it and then proceed with these steps. So that's why I have this next one for you right here, okay? Example, the next one. A titration of 25.00 milliliters samples of a hydrochloric acid solution of unknown molarity reaches the equivalence point when 38.28 milliliters of 0.4370 molarity sodium hydroxide solution has been added. What is the molarity of the HCl solution? That is your acid. Here is what you have right here. HCl is your acid, sodium hydroxide is your base, forming sodium chloride and water. This also, by the way, is a neutralization reaction. Anytime you have an acid and a base reacting together, you're going to always form a salt plus water, okay? So what you've got right here is the following thing that you, hello, Dr. Berry, my robot professor, how you doing? Y'all make sure you go follow Dr. Berry. If you love dealing with robots or you're an engineering major and you want to learn more about robots, she is your go-to person. She is your go-to person. Hello, Shohak. Yes, that's right. Blessed and highly favored. That's right. That's right. So Shohak, to address your question, you said, what is exactly as a titration? Creating a buffer solution? Yes. So the purpose of a titration reaction is to basically see how much concentration you have of one thing versus the other. Okay. So you may have to, let's say, create a solution of some products. And what you're trying to do is find out how much, meaning the volume of your other product that you need in order to find out the end point or the equivalent point. So for this particular problem right here, let's say that I tell you that I want a titration of a 25.00 milliliter sample of hydrochloric acid, but you don't know the molarity that it's going to take. Doing a problem like this will actually provide that information for you, okay? So what you'll need to do, thank you, Dr. Berry. What you'll need to do is write out all the information that you've got, okay? So in this particular problem, it is already balanced, okay? There's 1-to-1 to 1-to-1 ratios going all throughout this chemical reaction. So for the first part right here that we read through, they gave us 25.00 milliliters of hydrochloric acid. What I want you all to do is to automatically convert that to a liter, because whenever you're dealing with molarity, everything has to be in liters, okay? FYI. Now, did they give you the molarity of the base solution? Again, you got to know what is what. HCl, okay, that is your acid. Sodium hydroxide is your base. So did they give you the molarity of your base? Yes, they did, right here. Okay, let me highlight that for you guys. 0.4370 molarity sodium hydroxide, okay? So that is your base right there. So let me write that in, 0.4370, okay? That is your molarity. Now, let's keep going. The ratio of the base to acid is 1:1. There's an imaginary 1 right here in front of sodium hydroxide. That's why there's a 1:1 right there as well. Okay. The next part, the volume of the base solution. They told us this here as well, the 38.28 milliliters. So we're going to write that in right here also, 38.28. Okay. Whoops, I'm just making my numbers look different. 38.28 milliliters. Again, convert that to your liters, okay? Now, what two numbers are associated together? Well, from looking at this, I know that my volume of the acid was given and the molarity of the base was given. The volume of the base was given, but what is required? The molarity of the acid solution, hydrochloric acid. So what I do know is that these two right here, the bases, the molarity of the base and the volume of the base was given. So guess what I'm going to do? I'm going to start with those two numbers, okay? I'm going to start with those two numbers. So right here, I'm going to go ahead and start with the 0.03828 liters of sodium hydroxide. Now, in this next space right here, and let me zoom in so y'all can see that, okay? In that next space right there, I'm going to use my molarity of that base. But instead of me writing 0.4370 molarity, I'm going to write instead 0.4370 moles, okay, of NaOH over 1 liter of NaOH. Remember, molarity is moles per liter, okay? So that's what I have right there. Now, what are you going to do next? You're going to cross out those things that you don't need anymore, which are your liters. So let's go ahead and cross out the liters here. That's gone, that's gone. And now in this next step right here, you're going to use your mole to mole ratio, okay, of your base and your acid. Now, remember, I'm trying to get rid of my base. So on the bottom, I'm going to write this 1 mole right here. And remember, that's coming from your mole to mole ratios right here, okay? That's what I'm highlighting in blue. So I'm going to put 1 mole of sodium hydroxide on the bottom. And on the very top, 1 mole of HCl on the top, okay? Now, let's cross out those units because we don't need the moles of NaOH anymore. So now what's left over are your moles of HCl. So you know what we can do next, guys, right? We're going to go ahead and do what? Multiply those numbers. 3828 times 0.4370. That's equal to 0.01672 and so forth. We only need 4 of those numbers. So I'm going to write 0.01673. Okay. So that's equal to 0.01673 moles of HCl. Now remember, we're trying to get the what? Molarity of that acid solution. This is what we're trying to solve right here. I'm going to put that in yellow. We're trying to figure out the molarity, of the acid solution. And remember, molarity is equal to moles, which is this number right here that we just solved, okay? Divided by what? The volume, okay? Divided by the volume. the volume of the acid, which was the 0.02500 liters, okay? So when you do those two calculations there, all right, we plug that number in, divide by 0.02500, we get 0.6691, okay? That is our molarity. So M is equal to 0.6691 big M. Whoops, right there, okay? That's the answer. That's the answer. Any questions so far from anyone? Remember, titration problems, molarity, equivalent points. Think about what the word equivalent means. Equal. If I say we're equal, that means we need to be on the same page, okay? So that means you're going to have to use your mole to mole ratios here. That's something that we've talked about before when we were discussing stoichiometry a couple of months ago, okay? Or a couple of weeks ago. So when it comes to mole to mole ratios, you've got to make sure that you read your problem and look at what's given, okay? And again, you always want to check to see if the equation is balanced before solving the problem, okay? So I'm gonna let that breathe for a second before we go to the next problem. Yeah, show how that's what we're doing right now. Yes, that's what I'm doing right now. Okay. So here's another example, okay? Again, Alexis, it depends on what it is. Okay, what's your question? So now, if you take a look at this next problem right here, okay, it says a 20.00 milliliter sample of a solution of strontium hydroxide is titrated to the equivalence point with 43.03 milliliters of 0.1159 molarity hydrochloric acid. What is the molarity of strontium hydroxide solution? Okay. And let me make that a subscript of 2. Didn't do that. Now, when you are given problems of this nature, okay, they did not give a balanced equation. Okay, they did not give a balanced equation. Matter of fact, let me show y'all so that way you'll know what I'm talking about. Okay. Okay, Alexis, let me see what you got. Let's see here. What concentration of hitting? Say that again. Okay, so for that question, Alexis, put that on my last video, and I will have to go and do a video response to you for that one. Yeah. I'll do a video response. So type that question out for me again on my last video. Okay. 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 So as you guys can see right here, this problem right here, it says a 20.020 milliliter sample. See, they did not give a balanced equation. You're welcome. You're welcome. They did not give a balanced equation. And because they did not give a balanced equation, guess what? You would have to do that. And most chemistry teachers are going to do the same thing. They're not going to give you a balanced equation. And because they're not, some students will leave points on the table. That's like leaving money on the table. Because if you don't know where to start with your balanced equation, everything can go south real quick. And I'm not talking about 85 south, okay? I'm talking about south as in what we doing right here. So they told you strontium hydroxide reacted with hydrochloric acid. This equation is not balanced yet, okay? So we do have to balance the equation. And in order to balance the equation, we need to make sure that we got the equivalent amounts on both sides for everything, okay? So I know that I'm going to go ahead and put a 2 in front of hydrochloric acid so that my hydrogens will balance on both sides. I've got 1 strontium on the left, 1 strontium on the right. 2 oxygens on the left, and I got 1 on the right. And guess what I need to do? I need to balance that also. So I'm going to put a 2 in front of H2O. Now I've got 2 oxygens on both sides. I've got 2 chlorines on the left, 2 chlorines on the right. And I also have 4 hydrogens on the left. See, these two, plus the 2 right here, that's on the left. So I've got 4 on the right as well. Okay. So as you can see, this reaction is now balanced. You've got to make sure you do that. That's why I put this first step right here. Always check to see if the equation is balanced before solving the problem. Now, let's go through and make sure that we can fill in these marks right here, okay? Now, again, your teachers are not going to do this in terms of, well, I can't say they won't, but I'm giving you 5 points of spots you need to fill in, okay? You need to fill in these pieces right here. What you're looking for is the molarity of the acid solution. How do we know that? Well, and it's not the molarity of the acid solution. Scratch that. It's not the molarity. It's the base, okay? So I was copying and pasting this, so I did not go back and redo my my words. So let me redo that one. That's base. How do we know it's the base? Well, watch this. Here we go. It says a 20.00 molarity solution, milliliter solution of strontium hydroxide is titrated to the equivalence point with 43.03 milliliters of 0.115 molarity HCl. What is the molarity of strontium hydroxide? That is my base, okay? That's what we're looking for right there. That's what we're looking for. So what you're going to do is fill in what they gave you. The volume of the acid was 43.03 milliliters. You're going to convert that to a liter, 0.04303 liters. The molarity of the base, you don't know, okay? That's what you're looking for. So I'm going to go back in here because I was copying and pasting. I did not do my check, y'all. Forgive me for that, okay? The molarity of your acid was 0.1159 molarity, which is the same thing as saying 0.1159 moles per liter, okay? So they gave you that. Let's look at our chemical reaction. Strontium hydroxide has 1 mole, hydrochloric acid has 2. So we're going to put that in over here in this part of the chart, okay? So this is a 1 mole of the base to 2 moles of the acid. That's what I'm putting that in right there. Okay? So now, what you're going to do, excuse me, is find the volume of the base solution. And they told you this right here, the 20.00 milliliters. Again, we're going to convert that to a liter. Okay, now, what you're going to do next is use the 2 numbers that are associated with each other, okay? You're going to do what? You're going to multiply the 2 things that are associated with each other. The volume of the acid and the molarity of the acid, both numbers were completely together. So therefore, you can start with that part of your problem, okay? So what am I going to do? I'm going to first start off with the volume, okay? So 0.04303 liters of HCl, okay, times, I'm going to use my molarity right here, 0.1159 moles of HCl over 1 liter of HCl, okay? All I'm going to do next is just cancel out my liters because I don't need that anymore. And now in this next step that I'm highlighting in red, This part right here, your mole to mole ratio of your base to your acid. And remember, on the bottom, we want to get rid of the acid because we're not trying to use that. We're trying to find the moles of the base. So 2 moles goes on the bottom, and on the very top, 1 mole of strontium hydroxide, okay? Strontium hydroxide. Okay, right there. So let me zoom out a little so y'all can see the whole screen. Okay, there we go. Yes, Keandria, I'll do that. Yes, I'm gonna do that. And Destiny, yeah, come back. Just come on back. So, because you know you're gonna have a test on this, right? Okay, so Keandria, what part am I losing you at? Okay. So now I'm gonna go back through it again just to make sure you're good, okay? Because I don't want you to be confused. Okay, Mary, thank you. The ratio multiplication part, okay, let me do this part. So did you understand how I started off with this number right here? The 0.04303 liters of HCl times the molarity of HCl. You see how I multiplied those two, right? Perfect. When you get to this part that I'm writing in red, you need to use those coefficients right here. The moles of your HCl associated with the moles of your strontium hydroxide. Okay. So this is the part where you now have to put the moles of HCl on the bottom because we don't need that anymore. We're crossing that out. We don't need that anymore. But what you're trying to get to are your moles of strontium hydroxide, because in order to do molarity, is moles of your base divided by the volume of your base. So what we just found out was your moles right here. Okay. We're calculating this number right here in this step. So we're going to go ahead and multiply 0.04303 times 0.1159 divided by 2. And that gives me 2.494 times 10 to the negative third power. Okay. So when I multiply all of this across, again, I get 2.494 times 10 to the negative third moles of strontium hydroxide. That is my base. That is my base. And I guess what I'm going to do last, because this is the last step right here. I'm going to divide that by this number right here that I'm going to highlight for you in blue. This was my base, my volume of my base right here. So that's going to go right there on the bottom, okay? I'm going to put the 0.02000 liters on the very bottom. Yes, I am dividing moles by volume. And so that gives me, when I divide those two, that gives me 0.1247 molarity. Or you can say 0.1247 moles per liter. They mean the same thing. Okay. So, and again, Keandria, if you need to go back and look at the video, please do on my YouTube channel, okay? Learn chemistry with Professor TK the Chemist. Learn chemistry with Professor TK the Chemist. Thank you, Shohad. I appreciate that. I try to make them easy in terms of breaking them down, because I know that, some students need to see small pieces, small chunks. Alexia, Chad, this is a little basic calculator right here, okay? This is like $10. This is a Casio. Yeah, I don't even need a graphing calculator for the calculations that we're doing. Yes, Shohad, that is correct. No, Jocelyn, don't feel dumb, honey. Don't feel dumb. You're welcome, Alexia. You're welcome. Alexa, I'm sorry, I said Alexia. You're welcome, Alexa. But yeah, y'all, listen, this chemistry, yeah, I know it's a lot of steps. I really do understand that. But that's why whenever I do problems of this nature, I try to break them down in small chunks. You know what I mean? Like I try to do it in small chunks. And yes, there's a lot of highlighting. That's because when I highlight to pull out what was given in the problem. Then I highlight what do I need to solve the problem. And then I try to use different colors to show when the new step comes through. So that way you guys are able to see, changes within the problem. Okay. Would there be problems where they give product values instead of just reactants? Would the process be the same? Okay, let me see. Would there be problems where they give product values instead of just reactants? No. They're going to have to give you the acid and the base. And let me tell you this too. I'm glad you asked. That's a very good question. Thank you, Jocelyn. Because this is a neutralization reaction. No, Keandra, I haven't done heat exchange yet. No. Whenever you do titration problems of this nature, remember, it's always an acid plus a base reacting to each other, Shohag. So therefore, you're going to end up with a salt and water on the other side, depending on how it's stated. But you will always be given the reactants over here in order to solve on the other side, okay? But if they are looking for, let's say, strontium chloride, for instance, then they would ask you the question in a different way, but they have to give you the acid and the base in order to do the problems of this nature. Protein tracker, we balance the chemical reaction out. Yes, Shohag, that is correct. Yes, that is correct. That would mean you would have limiting reactants and you would have to determine which one of these products, is a limiting one as a result of what you had over here for the reactant. Yes. Now, this might answer your question also, Shohag, because here's a perfect example right here. They did not give a chemical reaction. Again, for this one, your teachers might be nice enough to give you a reaction and then tell you to balance it. But let me show you right here again. Here it is again. Okay. They did not give a balancing reaction. They're assuming that you would know to do that. So in order to do a problem of this nature, suppose we did not do, matter of fact, let me go back up here to the other one. Okay. So I can show y'all this. Suppose we did not even use the balance equation. If we didn't even use this part, if we didn't provide that, okay, this is blank. If we didn't provide that, guess what? Your answer would be wrong because this part that I wrote in red, this is based on the balanced equation. So if you stopped right here, okay, and you put 1 and 1 right there because you just assumed everything was good, then your answer, yes, would be doubled. That's right, Shohag. The molarity would have been doubled. You're absolutely right about that. And it will be doubly wrong. Okay. And guess what? There is an answer in your multiple choice questions that would be that based on doubling the molarity. Okay. And it will be doubly wrong. So yes, this is why I'm telling y'all right now, like I said in this question, always check to see if the equation is balanced before solving the problem, such as this one right here, okay? So this is the last problem that I'm going to do for the day before I have to go about my day, okay? Let's go through this problem. This is the last one, so you guys can see how to do them. A 35.00 milliliter sample of ammonia solution is titrated to the equivalence point with 54.95 milliliters of a 0.400 molarity sulfuric acid solution. What is the molarity of the ammonia solution? Okay, so again, let me make sure I have put in the right stuff here, because I know I just copied and pasted so that I wouldn't have to write everything out. But let me make sure I got everything I need right here. Let's see the volume of the, okay, right here. Okay, so now here's what you've got. Thank you, Shohag. So what you got right here, let's go ahead and highlight what we know. A 35 milliliter sample of ammonia. First number that they gave you was the volume of the base, 35.00 milliliters of ammonia, okay? 0.03500 liters. Next up, 54.95 milliliters of a 0.400 molarity sulfuric acid. So they gave you that too. The volume of the acid was 54.95 milliliters. Convert that to a liter, okay? And they also gave you the molarity. And I'm just going to write everything out in this so you all can see. Now, the mole to mole ratio. This step right here, we got to use the coefficients for my balanced equation. This equation, though, is not balanced, okay? I didn't balance the equation. I'm just going to do this really quickly because I don't have a lot of time, okay? But I'm just going to go ahead and put the coefficients in just so we can get through this problem. If you need to learn how to balance equations, I recommend that you book a consultation, okay? You book a session with me. I go live Monday through Thursday, 12 noon Eastern Standard Time. So for those of you guys that are new to me, I go live Monday through Thursday, 12 noon Eastern Standard Time. My evening schedule changes each week. So I will try my best to go live this evening. Okay. So for those of you all that need help, I will go live this evening. And if I do, you'll see it posted. Okay. If you have friends that need help, please let me know that too. Or let them know. Okay. So I just went ahead and balanced this equation out really quickly because of the time. All right. I'm going to use my coefficients from the base and from the acid. There is a 2-to-1 ratio, 2 moles for the base and 1 mole for the acid. Okay, so Keandria, are you still on with me, honey? If you still are, this is the part that I know you were talking about being confused about. Okay, so if you're still with me, this is for you. Okay, good. Okay, what's required is the molarity of the base. So what two things go together? The volume of the acid and the molarity of the acid. We're giving you that. So you know what you're going to do, right? You're going to plug in the numbers that are together. So I'm going to start off with the volume of the acid, 0.05459 liters, okay, of my acid. And I'm just going to put, no, let me say it the right way, because I don't want y'all taking shortcuts the way I'm doing it. H2SO4, I was just going to write the word acid out, but I'm just going to write the actual formula. H2SO4 times. This is where your molarity comes in, okay? My molarity goes right here in this next part. So that's 0.400 moles of H2SO4 over 1 liter of H2SO4. Okay, I got that from this part right here. Okay. Now, in this next step, and I'm going to put that in purple now. I'm going to do my, let's cross out those units we don't need anymore too, by the way. Okay, remember, I'm trying to get rid of my moles of H2SO4. So what am I going to do? I'm going to put 1 mole of H2SO4 on the bottom. And again, that's from this step right here, okay, that I'm highlighting in blue. So that's where the 1 comes from. On the very top, 2 moles of my base. Okay. 2 moles of my base. It's going to go on the very top. So I've got 2 moles right here of NH3. Okay. Again, we're going to cross out the moles of H2SO4, moles of H2SO4. Okay. And then I'm going to go ahead and multiply everything out. Okay. So 0.05459 times 0.400 times 2. That's equal to, let's write that out, 0.0436. Well, we only need, let's see here. Yeah, we only need 3 of those numbers, but let me round it off. 0.0437, okay? Whoops, moles of NH3 divided by, so y'all tell me, what goes on the bottom? The volume of the base right here. The volume of the base, okay? The volume of the base. And that volume of the base was 0.03500 liters, okay, of NH3. So let's divide those numbers on out. So 0.0437 divided by 0.03500, and you get 3 of those numbers, 1.25 molarity. Or you can say 1.25 moles per liter. Okay, that's it. That's it. And again, in case your teachers want you to put, you know, what you were talking about is of NH3. Okay, that was the ammonia. That was the base we were solving for. Okay. All right. So thank you, Jocelyn. I appreciate that. And again, guys, I try to download these videos on TikTok. It just takes so long, you know, for them to like release the video, let me download it, and then I have to edit it and all that good stuff. So that's why I go live now Monday through Thursday, even using my my YouTube channel so that you guys can go back and watch the replay. But I may try to sample some of these videos. You know, it just takes a little time, but you know, I'll try my best to do that for you guys. Okay. So does anybody have any more questions before we take off? Okay, what about stoichiometry? Alarm bug. Molarity, yes, I can do that, Keandra. Matter of fact, put that on my last video because, honey, out of sight, out of mind, I will forget. I will forget to do it. So put that on my last video as a comment so that way I'll remember that that's what you wanted me to work on. Molarity. I got you. And before y'all go, what states are you all from? That's what I want to know. I love knowing where my supporters are coming from. Like, what state you claiming? What state you claiming? Okay, what state? Oh, Pennsylvania, California, Kansas City, Washington. All right, I got a lot of West Coast love going on over here. Okay, Moa's from Florida. All right, Florida. I see you. Okay. Okay. That's good to know. Cali. All right. Yeah. I get a lot of West Coast love over here for sure. And I know it's early over there. Well, early meaning it's about, well, when I go live at 12 noon, it's 9 a.m. for you guys. Yes. So just make sure, guys, that as you all are going through this semester, which it is almost over, don't give up. Do not give up. Look, for my Florida person, do I need to play some Uncle Luke? Don't stop, get it. Y'all gotta keep going. You gotta keep going. No, I do not do inorganic chemistry. I'm sorry. Yeah, analytical. Yeah, I know that. Analytical is similar to this stuff right here. I mean, it is so many steps. It's a lot of math in analytical allures for sure. Yeah, Ma, look, don't stop, get it. Look, I don't want y'all giving up on none of this stuff because you guys have come too far. I hope you all have been going to your professor's office hours because if you haven't, listen, that's like a make or break point. When you all come to us during our office hours, we be looking out. We just can't announce it. You know, we can't be announcing that we're gonna give you a little point or two, you know, for coming to the office hours. But you want to go to the tutoring center, you want to go to the office hours so that you're able to get the extra help that you need. And that shows initiative to your professors. They love when you do that. We love when you guys come to our office hours, but you got to make sure that you're ready with your notes. Like, go have your notes on standby and then go through and say, look, I didn't understand this last step. So that way they don't think you're just, you know, just in there just to be in there. Okay, so yes, so are there any other questions before we go? Before we go, in terms of what other subjects that you guys need me to work on? I know, let me see. Let me go back. Keandra said molarity, so I got you on that. Bong said stoichiometry, okay. All right, guys. All right. So yeah, I appreciate all of you all that shared the video, liked the video, you know, hearted it up, all of that. That makes a big difference. You know, it means a lot. If you guys need any further help, you can always click the link in my bio to get extra help if you need that. Okay, click the link in my bio. Okay. All right, guys. Well, if there aren't any further questions, I'm going to go ahead and end my live. Okay. And thank you, Mo. I appreciate you, love. You're welcome, Keandra. You're welcome. And if you all need me, you know where to find